Hello everyone and happy Monday. Today we're starting our lesson off with geometric sequence word problems, okay? So you guys have already been doing a lot of work with geometric sequences. Now we're just going to kind of learn the same way we do with arithmetic sequences to take a word problem and turn it into a sequence and then an equation that we can use to predict any term. So, of course, you want to make sure that you always read the problem to yourself one time first. I'm actually going to make this a little bigger. You always want to, after that, you want to identify an initial value or a starting value for the sequence. That's the natural next step. Get that initial value. Then you want to identify that common ratio. And remember, this is the number that you multiply by to get from term to term in the sequence. After you get those things, it's really easy to write an equation that models a situation. And once you have your equation, you can find any term in the sequence, which is normally what it's going to ask you. Like, what happens if we want to look at the 100th term, the 12th term, whatever. You can find it without having to multiply everything out. Make sure that you always answer in context. If you're getting words in the word problem, you need to answer with words. So we're talking about in context. This means like a full sentence conclusion when possible. So let's just get right to it. Let's do our first example. And let's go through and highlight some important information as we read the first example, okay? So it says, a digital city map displays an area of 544 square units. After you zoom in once, the area is 272 square units. After you zoom in a second time, the area is 136 square units. So I realize that I'm starting with 544 square units. Question A says identify the initial value of the sequence. That's going to be 544, since that is what I started with before I did any zooming. And the sequence is described, or the word problem is describing a sequence to me. I get 544, then 272, and then I get 136 after one zoom, two zooms, and then three zooms. So that would be my sequence that I have here. I've got 544, then 272. My pen is like not cooperating with me today. And then lastly, 136. And we can just keep going in that fashion. And now I want to know, okay, well, how do I get from this term to this term, from this term to this term? And I know that I have to multiply. So I can do multiple things. I can take 272 and divide it by 544 to find out what I am multiplying by each time. And I would see that if I did that, I would get a common ratio of r equaling 1/2. And I can check again. Is 272 divided by 2 or times 1/2 136? Yes. So there's my common ratio. Write the explicit formula. All right, if you've forgotten what that explicit formula is, it looks like this. A sub n equals a sub 1 times r to the n minus 1. So I'm going to plug in everything that I know, which I know a sub 1. I know that that's 544, and I know r is now 1/2. So I can go ahead and plug that in to make an equation. And I'm going to leave n general so that I can find any term in the sequence if I want. So I've got 544 times, parentheses are important here, 1/2, to the n minus 1. There's my formula. What is the area after you zoom 5 times? So here I'm looking for n to equal 5. So I'm going to plug in my equation. N is 5. A sub 5 equals 544 to the 1/2 to the 5 minus 1 power would be 4. And Mrs. Sanderlin showed you how to use your calculator in a situation like this. We would do 1/2 to the 4th power times 544, and your final answer should be A sub 5 equals 34. And remember, we always want to answer in context. So for us, this would say, after we zoom 5 times, the area will be 34 square units. It didn't tell us if there's miles or what they are. That's okay. 34 square units. So there we go. Here's our final answer. All of this. Ew, I don't like the way that looks. I'm taking it back. Here's our final answer. Okay, let's do another one. Example 2, an archery competition begins with 256 competitors. Oh, that seems important. I'm going to highlight that. After the first round, 1/4 of the competing group remains. This sounds important. After the second round, 1/4 of the now smaller group remains. All right. So what's the initial value? Well, that word beginning tells me that that's my initial value, my starting point. So it's 256 competitors. Write the sequence that the problem is describing. Well, this 1/4 is my common ratio, if you notice. That is what we are multiplying by each time. I'm taking 1/4 of the group prior. So I started with 256. And since r is equal to 1/4, because that was given to me in the problem, I'm going to just multiply this by 1/4 or divide by 4, and I would get 64. And then I want another term. 64 divided by 4 is 16. And I could keep going, but 3 terms is enough. So I wrote the sequence that the problem is describing, and I found the common ratio. Now I'm going to write the explicit formula for the geometric sequence. Remember what this looks like. This is a sub n equals a sub 1 to the r to the n minus 1 power. So let's put it all together. I'm going to keep it general with a sub n equals a sub 1 is 256. R we found to be 1/4. And to the n minus 1 power. And now I can literally find any term I want in this sequence. The last round is when there are fewer than 5 members in the competing group. Which round is the last round? How many competitors are there in the final round? So this may not be very helpful to use the formula, but we could just say, I've got 256, 64, 16. All right, one more round would give me 4. So it says the last round is when there are fewer than 5 members in the competing group. And we hit that right here. So which round is the last round? Round number 1, 2, 3, round 4 is the last round. So we can answer that question. Round 4 is the last round. Which round, how many competitors are in the final round? So I can go one more after this. 4 divided by 4 is 1. So in this final round, there's only one competitor. So they won. After this, I would be going into some fractional type situations, and I can't model a person with a fraction, so we would be done in this case. So this problem was a little bit more unique than the other one because you may be given some information or other information. This one we were giving the initial value and we were given the common ratio, whereas before we were given the sequence. So you kind of have to be on the lookout and be a hunter and see what it is that you are given. And then use your formula down here to write an equation, but also you can use your common sense too. You don't always have to use the formula. You guys have a lot of knowledge when it comes to sequences, and if this way is easier for you, that might work out as long as there's not too many terms, then it can be too time consuming. So we'll let you use your judgment. Okie dokie. That was a quick lesson because we think you're fully capable of doing this on your own. Mrs. Sanderlin and I want you to do this, try this for homework. We will upload a key for you tomorrow for you to look at it. And remember, we love you guys. Stay safe, stay happy, and try and make the best out of your situation. We definitely are doing that. Lots of time with family and staying in contact with friends, check on each other, and if you need us, send us a remind. And this is your homework. Try this page, just these, OMG, just these couple problems. Problems 1, 2, and 3. Talk to you later.